Good morning, everybody. All right, it's May 20th. Who can believe it's May 20th? I feel like it's going by so fast, and I feel like it's been a while since I've done this live stream for chem class. So it's May 20th. Who can believe it's May 20th? Yeah, so let me just mute that. Hopefully everyone's doing well. It's gorgeous outside, so if you haven't had the chance, totally go outside. We set up our tent in our backyard just for fun for the kids to just sort of play in, sort of gardening. Hopefully you guys are enjoying the outdoors. Maybe get a chance to do some gardening as well. I think it's always great. So yeah, one thing that I wanted to tell you guys is that we don't know when the last day of classes are yet. I think they're still working on it. Grade 12s, yes, in a way, because the marks have to be due sooner than yours. For you guys, the marks for grade 11s and all the other grades, I should say, not just grade 11s, are due on June 23rd. Obviously, we're not going to have a final exam, so it's going to look a little bit different of what the expectations are. Most of what I'm thinking is that all of you will be required to do a self-assessment of the concepts that we have done. So it's a pretty thorough self-assessment that I'm making up as well. And then we'll just do ongoing sort of quizzes that you guys have been doing on Teams. Some of them are assignments, some of them are treated as like a quiz, but nothing like major like an exam, that's for sure. But yeah, so hopefully you guys all get a chance to go outside, because it's going to be so nice out today, and it's sort of bringing up my mood a little bit. So it's great. What I want to do today is I really want to wrap up this unit, and I want to finish off the limiting reactants. I know I got you guys to watch a video last week when I was sort of away, but I want to go over that as well, along with the stoichiometry. So I don't know how many of you have done the stoichiometry worksheet, but again, I also brought food in today. So here's a plate of just banana slices, and then I have these Kit Kat bars. So guess what I'm gonna do? I'm gonna make some Kit Kat sandwiches with a banana slice, and that's what I want to do. So the first question, what I want to show you here is that the formula I will have here is that I'm going to snap off the Kit Kat bar. So I have two. And what we're going to do is that I want to make a Kit Kat sandwich to look like this. Oh, like that. Okay, two Kit Kat bars and a banana will give me a Kit Kat sandwich. So my question here is that if I have 2 packs of these Kit Kat bars, right, how many Kit Kat sandwiches can I make? So you're probably looking at it's like, okay, so 2 Kit Kat bars, split them in half, so then I should be able to make 2 of these, right? 2 sandwiches, which you're right. So I'm gonna open this one up. This is all, I actually took this from my daughter and from her treat bag, so hopefully she doesn't find out or even come downstairs today, because then she's gonna be wondering where her treats went. So you notice that math was pretty straightforward, right? You have 4 slices of, or 4 pieces of Kit Kat, and it's on the screen, and you can only make 2 of these. Okay, so that's great. I was gonna eat them, but I forgot that I got other things right now. So that's pretty straightforward stoichiometry, right? Like if we were to write this, I have 4 Kit Kat pieces, and then if I want to figure out how many sandwiches I have, I do the times division bar, right? Kit Kat pieces at the bottom, that's the unit I want to cancel, and then the sandwiches at the top, because that's what I want. So I need to fill in my molar ratio. This is my recipe, right? 2 Kit Kat bars plus 1 banana slice gives me 1 sandwich, right? So I'm gonna put 1 here, that's the 1, and then 2 Kit Kat bars pieces right here. So cancel, and then you're gonna get 2 sandwiches, right? That's pretty straightforward. And this is really, if you know the if you know the setup for all of this, all of your calculations is exactly the same. That's why unit analysis is such a unique way, super effective way, right? So if you get massive numbers or decimal numbers, say that if we were to have like 0.8 Kit Kats, right? You do exactly the same thing times division bar 1/2, and then Kit Kat, and then sandwiches at the top. This will give me 0.4 sandwiches, right? Which we can't really eat 0.4 of a sandwich, but you get the point, right? That's how we use this. That's what we call stoichiometry. But instead of using the Kit Kats and banana slices, you have to use the unit moles, right? That's your stoichiometry. Let me just erase this. Now the next step of this is that it's a little bit different, and it's just like an added on to what we are currently doing with stoichiometry. Some of you might have watched the videos and might know what I'm talking about already. For those who haven't, let's just kind of go over this. The next little added to this is that now I have, let's say that I have these Kit Kat bars, right? I have 4 Kit Kat bars, but look at this massive pile of bananas, right? I have lots of bananas that I have. So my question is that you probably can figure this out just by looking at this. Just by looking at this, you have 2 ingredients with 2 sort of numbers, like finite numbers, right? Like 4 Kit Kat bars, and I have maybe like 12 banana slices. And now you have to figure, well, how many sandwiches do I have, right? So then you can do exactly the same as what I did, right? I formulated, or I put together, here's 1 Kit Kat sandwich right here. And then I make another one. Here's another sandwich with my banana. Now my hands are getting mushy and dirty, right? So I can only make a total of 2 Kit Kat sandwiches. However, what if I were to say that, okay, I don't actually have all these bananas, and I only have just 1 banana slice, right? Now I just have 1 banana slice. So ignore all this stuff. I only have 1 banana slice. Well, now you can see that I have just 1 Kit Kat sandwich, right? So the point of this is that this is what it's called limiting reactants and excess. What that means is that here in my plate of bananas, we have an excess amount of it. That means that we have more than enough, right? If we were to follow the recipe that we have, we'll make the sandwiches, and then eventually we're going to run out of Kit Kat pieces, right? We have run out of Kit Kat pieces. We can just make 2 sandwiches, but we have lots of bananas left over. That's the excess. So that's in chemistry, that's what we call in excess. That means it's just the excess amount. And then the Kit Kat bar here, each of these Kit Kat bar is what chemistry called the limiting reactants or limiting agent. That means that this is the one that sort of limits how much of the products you can make, right? So it doesn't matter if I have this massive pile of bananas, I can only make 2 sandwiches, because once these Kit Kat pieces run out, that's all the sandwiches that I can make, right? So limiting reactants or limiting agents is the one that limits or pretty much dictates how many products you'll have. And then the excess amount actually doesn't, because you have so much left over that I can have like a gazillion bananas, but if I only have 4 Kit Kat pieces, I can only make 2 sandwiches, right? That's what that means. So how do we relate that to a question or a moles or stuff like that, right? So just to give you a little bit of notes on this, we do have the notes here, right? I have the notes here, but I'm just going to bypass all this and just kind of talk about it. I feel like it's so much easier. So let's just kind of write this down. If you have any questions, just let me know. I'm so hungry that I want to eat one of these sandwiches. You're going to hear that limiting reactants, or sometimes you will hear limiting agents. They mean exactly the same thing. This one runs out first in the reaction. And because it runs out first, so this is just like the Kit Kat. Because it runs out first, this one determines the amount of products. right? Because just like the Kit Kat, that determines how many sandwiches we can make. And then if we have a limiting reactant, then we have something called in excess, which is just basically the excess amount. This is more than enough to be used in the reaction, RXN reaction. Okay, that means that you have there's leftovers. So this is my banana slices. Does that make sense? Like, if it makes sense, just type in the chat that, yeah, it makes sense for me. So then I know that it makes sense. So how do we relate this to moles, and how do we calculate it? Because now things are not going to be as easy to see in as like a Kit Kat bar and banana slices, right? You're going to get decimal places, you're going to get grams. So let's look at the first example here. Number one, this is making water. So you're basically synthesizing hydrogen gas and oxygen gas to make water. And this is saying that you have 50 grams of H2 and 25 grams of O2. And nobody said that they understood this in the chat. Come on, I want to see some action here. First thing you want to do is that you want to change all of this into moles first, right? So I'm going to put all this stuff into moles because moles is my central unit that I can use, right? So I'm going to put grams at the bottom and moles at the top. So let's convert all this into moles. So for every gram, 1 gram, I'm going to have well, wait, sorry, let me backtrack here. For the grams here, I need the molar mass, right? So this is my, let me just kind of backtrack here. I don't want to kind of go too fast. Molar mass is for H2. So notice that this is a diatomic molecule. So this is H2. You have 2 of these. So it's going to be 2 times basically 1 gram. So I'm going to have 2.00 grams, and I'm going to put 2.00 grams here. Okay, so you're going to see that the grams will cancel out. There we go. I get like 3 responses out of 17 people watching. What's that? The other people doing here? I'm going to hear yeses from everybody. 25 grams. Well, not 25 grams. I'm distracting myself. It should be 25 moles. Right? And this is moles of H2. That's the first thing. That's the moles. The next one is I will need to find the moles of oxygen. So I'm going to do the same thing. So times division bar. And put grams here, moles here, and then 1. And then my molar mass of O2 is going to be 2 times, I'm going to round this, so it's 2 times 16 is equal to 32 grams per mole. So if you don't know where this number is from, this is from the periodic table. That's your atomic mass, right? And on the periodic table, it's like 15.99 something. I'm just going to round it off to 32. And then I'm going to cancel my grams, and then I'm going to calculate this. So if you want to do this with me, I'm going to have a couple of questions for you guys to do as well. 25 divided by 32 is going to be 0.781 moles, and this is of O2. It's always good to put of O2 so you know what you have now, because we're using stoichiometry, right? There we go. We have 4 people saying yes, they get it out of 16. Some people actually dropped and left because of that. Okay, so the next thing is, okay, so you have 25 moles of H2 and 0.781. These are supposed to be your Kit Kats and banana slices, which, how are we supposed to make sense out of this, right? Like, how do we piece it together? So one really good way is that now you have to figure out, if you were to use this H2, how much of O2 do we need to use with that? Okay, so what that means is that I'm going to set up this table that is going to be super user friendly, and once you see it, once you do this, it's going to just make life so much easier. So this table is that you're going to put your both reactants, okay, your H2 and O2, and then you're going to have a column, a row for have. This is what you have, currently have. And then you're going to have a row for what you need in reality, okay? And then this is going to be your difference. So what do we have right now? we have calculated that we have 25 moles of H2. So we have 25 moles of H2. How many oxygen moles do we have? We have 0.781 moles. Okay, so this is what we have. Now we have to figure out how much we need. It's just like the Kit Kat and the banana slices. If I have 2 Kit Kat pieces like this, maybe this angle might be better. How many banana slices do I need, right? Well, for every 2, I need 1 banana slice. That's what we're trying to calculate here. And in order to calculate that, we need to use the stoichiometry with the molar ratios. So how do we do that? We're going to set up the same sort of division bar, right? I'm going to change colors here. So let's try to use moles of H2 first. 25 moles of H2. This is what we have so far. This is what we have. And then we're going to figure out how much of the oxygen that we need. So I'm going to put moles of H2 here and moles of O2 up there, right? Because that's what we try to find. And then the molar coefficients here, that's those are the numbers from the recipe, right? So what's the molar ratio? This is 1, 1, and then 2, right? Hold on a second. Should be 2, 1, 2. Should be 2, 1, 2. That's the molar coefficient. Let me calculate the math. Looks good, right? So the number in front of the O2 is going to be 1 because that's the coefficient. And then the number in front of the moles of H2 is going to be 2. Again, this whole setup is calculate how much of this O2 do we need, right? So we're going to cancel off the moles of H2. And then what you're going to have is you're going to have moles of O2. This is what you need if you were to have H2. Okay, maybe it sounds kind of confusing, but seriously, once you see the table, it makes sense. So do the math here. You're going to get 12.5 moles of O2. So I'm going to put this 12.5 here. This is O2, so I'm going to put it under the O2 column. So this is 12.5 moles. So if you look at this, use some rationale and some logic in here. If you have 0.781 moles of O2, let's say like if you have a very small amount of O2, but you need this, is this going to be, do you have more than enough, or is that going to be your limiting reactant? As in that, is this going to be used up first? Well, if you look at this number, if you subtract this number, this 0.781 to this, you're going to get a negative number, right? So this, because of that reason, is going to be your limiting reactant. That might be a difficult, more challenging one to see. Let's look at the other side, right? Let's look at how much of this H2 that you need. So in order to calculate that, you're going to use 0.781 moles of O2 times division bar. And we're going to have moles of O2 at the bottom. And we want to find the moles of H2. So I'm going to put that at the top. And then the ratio is going to be 2 to 1. It's going to be opposite of this one. So we're going to cancel out different things. So moles of O2, moles of O2, that's going to get canceled. And then what you're going to find out is that you're going to get, what, 0.1, I'm going to do this in my head, 6 moles of H2. So this is what we need when you have this amount of O2. Does that make sense? Okay, maybe that might be a little bit tricky. So let's just fill in the table right now. If you have any questions, let me know. So I'm going to put 0.156 moles here. Okay, so if you look at this, I think now the table makes a little bit more sense, right? Because if you look at the amount of H2 that you have 25 moles of it. Basically, it's like 25 slices. And then you only need 0.156 slices. Do you have more than enough? Yeah, it's just like the bananas, right? I have lots of slices, right? But I only need 2 of them, right? So then this one, if you were to subtract it, you're going to get a positive number. And this is what you have, the excess. So this is your in excess. So this is the excess amount. So that's, you're going to have more than enough here. And then for O2, You don't have enough, so this is your limiting reactant. So what you just did, setting up this table, is solving for the limiting reactants. So why do we care about this? Well, just like the Kit Kat and the banana example, is that once you have two items in the reaction, one of them is going to run out first, right? The Kit Kat ran out first. The Kit Kat is the one that determined that I can only have two of these sandwiches, right? Not the bananas. Just like in this reaction, oxygen is the limiting reactant, so this is the one that determines how much products that I'm going to get. So if the question were to ask you, how much water would you get from this reaction, right? How much water, how many molecules of water will you get? What you're going to do is that now you're going to go to the next part and you're going to use the oxygen. You're going to take this amount, 0.781 moles of O2, right? And then times the division bar, moles of O2 and moles of H2O, because we're trying to find H2O, and this is what we're trying to get. We don't use the H2 because that's the in excess, that's the abundant amount, right? That's more than enough. You want to use the one that you use everything of, right? So I'm going to put this the molar ratio here, so it's going to be a I'm going to have a 2 for this one and then 1 for the oxygen, right? 2 here and 1 for the oxygen. And then I'm going to, let me kind of scroll down here, and I'm going to cancel off the moles of O2, and then you're going to get the same amount, 1.156 moles. Now you don't have H2, you have moles of H2O. So this is H2O. So in summary, if you were to react 50 grams of H2 and 25 grams, you're going to make this amount of H2O. You can change this into the volume, you can change this into the mass or the molecules. That's what you need. So I need to figure out the limiting reactant first, because the limiting reactant determines how much products you'll have. Does that make sense? I have 17 people watching. I want to hear you guys if that made sense, because then we're going to jump into a more challenging example here. I'm going to eat one of these sandwiches. Oops. Here's the second example. My answer is kind of off. Which one? What you're talking about? I did it in my head tune, so let me know. For the whole time. Suppose 2.00 grams of NaCl. Thanks, Annie. You're so kind. Reacts with 5.00 grams of silver nitrate to form this and this in a double displacement reaction. So here's the next step up. You're provided with the names, and then now you have to put into the products. So first thing I want to do is to write the reaction. NaCl reacts with AgNO3, which is your silver nitrate. This is actually a reaction that we do in the lab. And then because this is double displacement reaction, I'm going to get NaNO3 and AgCl. So next thing is I want to figure out, did I write these formulas correctly? Right? Because I need to look at the charges for each of these. So Na is a +1, NO3 as a polyatomic is a -1. So this is +1, -1. So this is actually good. It cancels out to 0, so it's neutral. Silver is a +1. Chlorine is a negative, so this is also good. So right now we're sort of lucked out that we didn't have to cancel out the charges. The next thing is that I need to balance the reaction. Do I have the same amount of these atoms on the reactant side to the product side? And you can see, because since they're all 1 to 1 to 1, they're all going to be 1 to 1 to 1. So this is actually a pretty straightforward reaction. So the next thing here is that I'm going to write 2.0 grams. I'm going to just, okay, fine, 2.00 grams here and 5.00 grams here. First step I want to do is what? Figure out the moles of each. So I'm just going to put 2.0 grams of NaCl times division bar. I want grams at the bottom because I'm trying to solve for moles, so I put moles at the top, right? This is not stoichiometry. I'm just converting grams into moles, right? So I put 1 moles here, and for NaCl, I need to find the molar mass of this. Okay, NaCl, I'm going to try to do this in my head. I don't know silver on top of my head. Na is going to be 23 plus 35. This is, again, rounding this off. So this is going to be 58 grams. And I'm going to put 2 divided by 58. And I'm going to get answer 0.0. Wait a minute. Is that right? 58. 0.0. I'm going to double check my math in case June is going to tell me I'm wrong again. Moles of NaCl. So that's the moles of NaCl. So far, so good. The next step is that I need to figure out moles for silver nitrate. So I'm going to put 5.0 of AgNO3 times the division bar. And I'm going to put moles at the top and grams at the bottom. Now I need to figure out the molar mass of this. So I need to know, I don't know the silver, I think it's what, 70, 79 molar mass of silver. Top of my head. Oh, silver is 107. So silver is 107.8682. Nitrogen is 14. Again, these ones are rounding. And then oxygen is going to be 3 times 16. So I need all of this stuff added together. I think 3 times 16 is 48. So I need 48 plus 14 plus 107.86, etc. So I'm going to add all this stuff together. So you guys can totally try this as well. 107.8682 plus 14 plus 48. I'm going to get a number of 169.8. I'm going to round it off to 0.87. And that's for every 1 mole. So that is the molar mass of silver nitrate. Yeah, so like the numbers is tough. And then as you get practice, it's actually like the same stuff all the time. What you're going to do is that you're going to divide these, right? So I'm going to do 5 divided by 169.87, and then you're going to get cancel out the grams. You're going to have 0.029 moles of silver nitrate. Okay, so what we just did was just solving for the moles. No stoichiometry, no limiting, no excess or anything like that, right? This is the first step that I taught you about molar conversion, right? If you think about this unit, it actually builds on each other through layers, right? We learned about naming, which is what you have to know. You learn about balancing the charges to get the right formula, right? You learn about types of reaction. This is a type of reaction. And then you learn about balancing. This is you have to balance. And then the next one was moles, right? So this is the moles here. So the next step here is that now you have to figure out limiting reactants. Again, you only need to set up this table if you have 2 reactants provided to you, right? Just like that banana and Kit Kat, you have provided with the amount of the bananas and the Kit Kat. This one you provided with the NaCl and the silver nitrate. So I'm going to set up my table, and actually I'll just do it like right here. I'm going to have my both reactants, NaCl and a silver nitrate. Silver nitrate here, and then I'm going to do a little grid. I'm going to have a have. This is what I have first, and then this is what I need. You want to start off with what you have first because this is what your starting point is. So what do we have right now? We have 0.034 of NaCl. These are, again, moles. That's why we need to use moles. And the next one is 0.029 moles. I know this step might involve a lot of like calculations, but guaranteed if you do this, you'll never get it wrong. And if you even get it wrong, I look at your work and it'd be like, okay, you pretty much got the gist of this. And it's just maybe your calculation error and you won't lose as much marks. But if you were just to give me like, oh, this is the limiting, this is the excess from nowhere, then I'm like, well, you probably just guessed at this, right? So it's really important to show your work. So right now we have the haves. We need to figure out the need for both of these. So it doesn't matter which one you choose because we're going to use both of them anyways. So since I use NaCl first, I'm going to use NaCl and I'll change the colors. So this is to figure out the haves and the need. So what I have is that I have 0.029 0.034 moles of NaCl times division bar. Now this is stoichiometry, so then for stoichiometry I need moles of NaCl, and then I need moles of, what are we trying to find? Silver nitrate. So I'm going to put silver nitrate here. And because this is stoichiometry, because we're looking at the moles, we need the molar coefficients, and luckily all the molar coefficients are 1 to 1 to 1, so really actually makes everything super easy now because they're just all 1 and 1s. Cancel out the moles of sodium chloride, and you're going to get same thing, same number, but now you have moles of silver nitrate. So you're going to put moles of silver nitrate in the need here. So this is going to be 0.034 moles. And just by looking at this, can you determine if one is limiting and one is excess just by these two numbers? Well, if you look at this, you have 0.029 and you need 0.034. So you actually don't have enough. So you don't have enough. And because you don't have enough, sorry, this is off the screen. This is, if you don't have enough, this is going to be your limiting reactant automatically, and this one has to be excess. And if you don't believe that method, then you can totally figure out the need here and then find the difference, and you're going to find out that this is the excess. Okay, so look, let's try that, right? Let's try right here, 0.029 moles of silver nitrate. And you're going to notice that this is kind of redundant because the molar coefficients are all the same, right? So this is NaCl, this is all 1 to 1. So you're going to get 0.029 moles of NaCl. So I'm going to put this 0.029 moles here. So if you look at the table now, if you look at this and you have this amount and you need this much, so you do have enough, right? Because you have more than enough. That's your excess. You just double check your work. So you don't have to do both of those, but it's up to you. But it's a good way to just sort of to verify your work. So after doing all this, what is the purpose? The purpose here is that this is the limiting. So the silver nitrate is the one that determines how much of the products you're going to have. So from now on, you're going to use this number and not the excess number, because excess will not determine how many products or how much of the products you will have. So if the question is to ask you, well, how much silver chloride did you make from this? What you're going to do is that you're going to take this number, and then you're going to use and figure out the moles of this number, right? So if you're going to take this number, I know there's a lot of writing here. I'm going to take this number, moles of silver nitrate, times the division bar, and the moles of silver nitrate. And now I want to find moles of silver chloride. So I'm going to do the mole to mole ratio, and then you notice that they're all the same. So basically you're going to get the same number, 0.29 moles, but now you have silver chloride instead. And once you have the moles of silver chloride, you can find the mass, you can find the molecules or whatever, right? That's why we use limiting reactants. I don't know how that worked out for you. Hopefully you guys all follow along and made a little bit better sense. Here's another one, and let me know. I'm gonna move this down a little bit so everything is all here. Give this one a try. So like right now, give it a try right now. You have 1.5 grams of calcium carbonate. So the first thing you need to do is figure out what the formula of this is. If you want to type it in the chat, what's the formula for calcium carbonate? This is going to react with HCl in the double displacement reaction. So the next one is you're not provided with the products. You have to figure it out. But you do know that one of them is going to be calcium chloride. And then you have to know that this is calcium CaCl2, right? So try that. you should notice that this is going to be CaCO3 plus HCl plus this double displacement. So these, I'm just going to choose the cations and switch in places. So I'm going to get H2CO3. Okay, that is your reaction. So the next step is that, what do we do? What's the next step? Balance the reaction. So I'm going to see if I can balance this. 2 here, and then we're gonna have, okay, I think it's just 1, 2, 1, 1. Is that right? I think that looks right. And then give this question a try. Find the moles of this. I'm gonna totally let you guys do this right now because I think we've done enough. I've done enough. So I'm gonna leave it there, and then I'm gonna post up the answer here right after this video. But I want you guys to do this right now, just to let me know about your understanding of this limiting reactants and excess. Okay, so I'll just kind of sit here in front of the screen for like a couple minutes, but give this one a try. Like seriously, go get a pen and paper and give this one a try. Oh yeah, I got stuff I can eat. This is great. I want you guys to tell me what the answer is for calcium chloride. How much of this are you going to make? And change this into grams. Okay? And then type it in the chat so I know you did it. Guy, you can use the internet. Just ask Siri. Moles 1. 40 plus 12. So this is 40, 12, 3 times 16, 48, 60, 100 grams. So this is going to be 0.015 moles of CaCO3. Super rough estimate. Moles of this one, 0.73 grams times division bar, grams moles. 1 HCl, this is going to be about 36 point, I think like 4.5 or something like that. So then this is going to, I can't do that one in my head. 0.73 divided by 36.45. So this is going to be 0.02 moles. So that's what I have. What you're going to do now is set up the table. CaCO3 and then HCl. This is my have and this is my need. And then figure out the difference. So I have 0.015 moles here and then 0.02 moles here. I'm just going to choose one to figure out what I need. I'm going to use the CaCO3 since I have it listed first. So this is going to be moles of CaCO3 times division bar, and then moles of CaCO3, and then moles of HCl. So now I need to go back and find the molar ratio. So I know that HCl is 2 and then it's 1, so it's a 2 to 1 ratio. So I'm going to get 0.030 moles, and then now I'm going to cancel out the moles of CO3, and then this is going to be HCl. So this is what I need, and this is what I have. So I'm going to need this amount. So now you have to look at this and figure out, hey, do you have enough, right? You have this amount, but you need this amount. So this is where it gets a little bit tricky because you have small numbers and decimal numbers. You have 0.02, you need 0.03, so you actually don't have enough. Don't have enough, and because you don't have enough, then this is going to be your limiting reactant. And if you solve for the CaCO3, you should have a positive number. That means that this should be your excess. You have more than enough of this. Okay? And then once you have solved for all of this, now we need to figure out how much of this calcium chloride that we have, right? So I'm going to take this number, the one that you have. Again, we're going to take this number, the one you have, not the one you need. You're going to take the one that you have of HCl, moles of HCl, times the division bar, and then moles of HCl at the bottom. And then you want to figure out your calcium chloride, right? CaCO2, is that right? Yep, that's what I want. And then the ratio between these two are going to be 1 and 2. So it's like 1 to 2 ratio. So it's actually half of it. So again, this is your stoichiometry using moles and cancel out HCl. And this is going to be 0.01 moles of CaCl2. Are we done right now? No, we need another step because right now we just know the moles of this. We want to figure out this in grams so that we have something tangible, right? So do a molar conversion, 0.01 moles of CaCl2 times division bar, and then I'm going to have moles at the bottom and then grams at the top, right? This is finding molar conversion. So I need to put the molar mass of this into here, okay? So Ca is going to be, I think, 40 grams of molar mass, grams per mole. Chlorine is going to be 2 times 35, so this is going to be about 70. Again, this is just all rounding off top of my head. So you're going to have 110 grams for 1 mole. So this is the total molar mass of CaCl2. And then now you're going to multiply all this stuff together, and you're going to find out that you're going to get 1.1 grams of CaCl2. I hope that's the answer because I totally did that in my head, but I believe it is 1.1 grams, right? So what did we just calculate? We calculate that if you were to mix 1.5 grams with 0.73 grams, you're going to get, theoretically, 1.1 grams of CaCl2. Obviously, if you were to do this in a lab, your numbers are not going to be 1.1 because there's a lot of errors that can occur. So when you think about when people are synthesizing drugs, those techniques has to be perfect because that's what, those synthesizing drugs, putting it together, that is really all of what we're doing, right? We're calculating the theoretical amount. This is the amount. If you were to get 100% yield, that means 100% of your products will form 1.1 grams will be your theoretical amount. Okay, that's your limiting. That's the end of our chapter 3 or unit 3 on chemical reactions. You've learned quite a bit in here. Obviously, unfortunately, we are not in a lab that we can't have you guys do this because it's one of those things that if you do it in a lab, you probably understand this a little bit better. But that's it. Hopefully this has helped you. And I believe I have a quiz assigned to you for this week as well on limiting and molar conversions and stoichiometry. So don't forget to do that. And we'll start a new unit on next week. I don't want to start a new unit on Thursday. Is it today is Wednesday? On Thursday, right? What day is it today? Oh, we missed the class, right? Yeah, so we'll start out our next unit on Monday. But if you have any questions, please let me know. If you look at this, if you look at this in your work booklet, you should have completed all this stuff. And if you're unsure, the title tells you what the topic is, right? So 85 is about stoichiometry, and then 80. Once the page loads, 88 is limiting and excess. So that's what you want to do. By the end of this week, you should be able to be done up to page 91. Don't worry about the empirical formula and the percent for our time being. So don't worry about this, and then don't worry about this. But give the review a try because I think it is a good review for you guys to do. And then that's about it. So at the end of this, you should be able to finish all the way to I don't know, 100 and something, page 100. Okay, well, I shouldn't cross that out, but that's it. But yeah, like look at the title, look at the topic title at the top of the page, and then it should say that. And then next week we'll start our unit on solutions. All right, and then we'll do like a day where we'll make ice cream. So thanks for coming in. If you have again any questions, let me know. That was a longer video. It was one of those where we had to go through some questions, but yeah, thanks for coming by. I'll see you next week. Have a great weekend. Yeah, I guess so. And go outside. It's super nice. Bye.